Welcome to the EPG Pathashala program, the lecture series in computer science on the course Compiler Design. This module will talk about the left factor of the grammar, computation of first and follow, and finally constructing the parsing table. The objectives of this module are again to design the top down parser by constructing the functions first and follow, and to learn to construct the LL of one parsing table. The first and follow are two functions which indicates that what is the first symbol which is a possibility, and then it will also indicate what can follow a particular symbol. That is what follow basically indicates. Now, using these two components of first and follow functions, our LL parsing table is constructed, which is going to be a table between terminals and non-terminals. Non-terminals are going to be the rows and the terminals are going to be in the columns. The keywords are first computation, follow computation and parsing table. Last module we discussed about the left recursion elimination. Left recursion elimination is A produces A alpha or beta. So, if there is a production, then that A production should be converted to a non-A production, meaning that it should be converted to the left heavy grammar should be converted to a right heavy grammar. Okay. So that there is backtracking is very much avoided. Similarly here if I have productions of the particular form alpha beta 1, alpha beta 2 etc. up to alpha beta n or gamma, now all these n productions belong to requires left factoring because the prefix is the same for all these productions, and the last production is a non left factoring or it does not require any factoring. So what you do is we have to replace this with a new non-terminal. Again we will introduce a new non-terminal, call the non-terminal as AR, and have only one production here as against n productions, call it as alpha AR and then or gamma. So this gamma is here, okay, and then AR will be replaced with AR will produce beta 1, beta 2 etc. up to beta n. Now what is the advantage here? Anyway it is going to start with alpha only. Till this particular point there is definitely no backtracking possible at all. So only after AR we will know the first symbol we know. So we will know that whether to replace it with a beta 1 or a beta 2 or etc. up to beta n. So this is going to be avoiding backtracking to a greater extent. Now let us take this example. Statement produces if condition then statement or if condition then statement else statement or A, and C produces B. Now this is the famous if then grammar only, which we have talked about in the previous module. Here I have underlined things which are common between these two productions. So this is my alpha here. Now beta 1 is epsilon here, beta 2 is ES here. Okay, beta 1 is epsilon and beta 2 is ES here, and this is my gamma, gamma is A here, and this C does not have any problem at all, C produces only B. Now the modified grammar is I am introducing a new non-terminal S dash, and this is got now if condition then statement statement dash, that is alpha followed by S dash, and this S dash will produce else statement, or that is S dash will produce beta 1 or beta 2. So that is your beta 1, this is your beta 2. Now this is, and the C produces only B, there is no problem with C at all. Now this is the computation of left recursion elimination and there is left factoring which is happening. Now after this the modified grammar whatever we have, so first we remove left recursion, get a new grammar, that grammar is checked for whether it requires left factoring, okay, it is removed if necessary, and then you have a modified grammar. Now this grammar is what is going to be used for constructing the predictive parsing table. Now there is already indicated, the first L indicate input is scanned from left to right, the second L indicates you are applying a left derivation, and the 1 indicates there is looking at only one input symbol at a particular point of time. Okay. So predictive parsers are basically LL1 parser. So how do I go about? Left factor the grammar, compute first and follow, okay, and then construct the parsing table, or you can use a recursive procedure, okay, to do the parsing actually. Now the non-recursive procedure is a table driven approach. We are going to go with that approach only because it avoids backtracking to a greater extent. First of 1. Now if I say first of 1, this is being used by LL of 1 parser. Then is there a first of k available? Of course first of k is also available. You can have first of 3. What 3 symbols will occur as the first? okay, will occur as the first 3 symbols of a particular string, that is first of 3. First of 2 means what 2 symbols can occur as the first 2 characters, okay, that is first of 2. Now here first of 1 indicates you are looking at only one symbol. What can be the possible first symbol in a string given a particular non-terminal? And this first function is typically computed for all terminals and non-terminals. Rather, first of alpha will be equal to the set of terminals that begin all strings derived from alpha. Okay. First of alpha, I can also look at for first of alpha. What is alpha? Alpha is a combination of terminals and non-terminals. So, what is the first character that will start? Okay, that is going to be first of alpha. That character will be the first character in your string. That is what we basically mean here. For example, first of A is a terminal, A is a single character, first of A is A, and first of epsilon is also epsilon, only one character is there. Okay. First of capital A is equal to union of all A producing alpha, first of alpha. Supposing A has got multiple productions, each of these productions will basically have a first symbol. Now, each of those first symbol will belong to first of A. Okay. So, if supposing A has got only 2 productions, one is capital A produces small a, other one is A produces capital B, then first of A will include small a as well as capital B, okay, first of capital B rather. So, for all A producing alpha belonging to the productions of P of the grammar. Now, this is the algorithm. First of x1, x2 etc. up to xk. Now, this is your alpha is equal to, if for all j is equal to 1 to I minus 1, okay, epsilon belongs to first of xj, then add non-epsilon in first of xi to first of x1, x2 etc. up to xk. If for all j equal to 1 to k, epsilon belongs to first of xj, then add epsilon to first of x1, x2 etc. up to xk. Now, this is the algorithm, the interpretation of the algorithm. For example, first of this particular combination will have first of x1, obviously, that is understood, because first of alpha is whatever is this first character, that will be the first of this particular combination alpha. Now, supposing there is a production or this first of x1 contains epsilon, okay, if this first of x1 contains epsilon, then first of x2 will also belong to this first of x1 to xk. So, it will have first of x1 as well as first of x2, because x1 produces epsilon, or in other words x1 has its first component as epsilon. Okay. Supposing x1 is a non-terminal, then x1 could produce epsilon. Therefore, if x1 produces epsilon, then this combination basically can be derived as x2 to xk also, in which I will include first of x2 also to be the first of x1 to xk. Subsequently, if I have x3 also produces epsilon, okay, x1 produces epsilon, supposing x2 also produces epsilon, then first of this combination will also include first of x1, first of x2 and first of x3. So, that is what it basically says, epsilon belongs to first of xj, then add non-epsilon in first of xi. So, this is from 1 to I minus 1, where you are looking for computing the first of xj. Similarly, here you are computing from j equal to 1 to k, and you are going to compute first of x1, then add epsilon to first of x1 to xk also. So, this is the algorithm. Using that, let us do that problem after we discuss follow is typically done for non-terminals. The definition is set of terminals that can immediately follow a particular non-terminal, okay, that is your definition. Now, follow has got 4 rules. The first rule is, if A is a start symbol, add dollar to the follow of A, okay, and then you have to look for other productions. Now, your productions can be some capital B producing alpha A beta, that is there is a non-terminal here available. After that I have a beta. Now, this beta could be epsilon or not, does not matter, okay. That is what we have broken this rule into 2 components, first one and the last one. So, if I have alpha A beta, then follow of A will contain first of beta, follow of A will contain first of beta, that is B produces alpha A beta, alpha could be epsilon, I do not care, and following A, if I have a beta, then follow of A will contain first of beta. That is what this basically says. First of beta, you have to add every symbol to A except epsilon. Okay. So, add first of beta except epsilon to follow of A, that is the first rule. The second rule says, again looking at a production in this particular form, B produces alpha A beta, and supposing first of beta contains epsilon, then how will this production reduces to, it actually becomes B produces alpha A only. Okay. So, in that case, follow of A will contain follow of B, that is what it has we have said here. Add follow of B to follow of A, that is include follow of B to follow of A. So, follow of A here contains follow of B. Okay. So, follow of A now will have all the symbols available in follow of B also. And the last rule is, look for B produces alpha A. If B produces alpha A, now once you look at this alpha A beta, if beta can be substituted to the epsilon, this production is similar to this production, right. So, this is an indirect production, this is a direct production available in the grammar itself. So, B produces alpha A, if that is a production, again follow of A will contain follow of B. So, 3 rules typically other than the first rule. The first rule is simply adding to the follow of the start symbol. Subsequently, 3 rules. One is B produces alpha A beta. This follow of A will contain first of beta. So, first of beta you have to add all symbols to follow of A except epsilon. Okay. You would have already computed first of beta. Okay. You have to add all symbols except epsilon. And on the other hand, if this beta first has got an epsilon value, you can substitute that and this production reduces to B produces alpha A, right. In that case, follow of A, you have to add to follow of A the follow of B components also. It is a union computation, it is not a replacement. So, that is why we say follow of A contains follow of B. You have to keep on accumulating to follow of A, the components of follow of B also. Now, the last one is a direct production is available. B produces alpha A. Again, alpha could be epsilon or not does not matter. B produces alpha A, that is it is ending with a non-terminal. Okay. In that case, follow of A will contain follow of B. Okay. Again, the same rule. These 2 rules are same, except for the fact that this is an indirect alpha A, this is a direct alpha A. Okay. Now, based on these, let us just get to the left recursion eliminated expression grammar. So, we had actually E produces E plus T, T produces or T, T produces T star F or F, F produces parenthesis E close parenthesis or, this is your actual, I mean earlier we had a grammar and that has been modified after removing left recursion to this particular situation. So, E produces T E dash. E dash was our new introduced non-terminal. Okay. We have introduced this non-terminal E dash. So, E produces T E dash and E dash produces, there was a E plus T. Okay. So, plus T is your beta. So, beta followed by E dash or epsilon and T was T star F. Okay. So, that F or F. So, with this F we added T dash and this star F was brought here with a T dash at the end or epsilon. This production remains as it is because F does not have a left recursion at all. Okay. Now, computing first. If you remember the previous slide, first of E is first of T. First of T is first of F. First of F is first of this as well as first of this. Okay. Now, T does not produce epsilon, F does not produce epsilon. So, therefore, there is no accumulation of first of E dash to first of E or first of T dash to first of T. So, first of T will be contained in first of E, first of T is equal to first of F, first of F is first of this particular symbol and first of this particular ID. Okay. So, let us just do that first. First of E is equal to first of T is equal to first of F. So, indirectly E produces T E dash, T produces F T dash. So, first of E will be first of T, first of T will be first of F. What is first of F? First of F will be first of open parenthesis E close parenthesis and first of ID. First of ID, first of A, first of a terminal is itself. First of alpha is equal to, if the first symbol happens to be a terminal, it is that terminal only. If the first symbol happens to be a non-terminal, then we have to go as a chain. Okay. So, first of open parenthesis E close parenthesis is open parenthesis only. So, first of E, first of T and first of F is equal to open parenthesis comma ID. First of E dash. First of E dash is the first symbol which is plus or epsilon and epsilon. Two symbols are there. Similarly, first of T dash will have a star and an epsilon. So, plus here because that is the first symbol, that is a terminal. So, there is no more additions happening here. Epsilon, that is the only symbol, first of epsilon is epsilon only. Okay. First of T dash is star. So, first of star is, first of a terminal is terminal itself. So, which is star comma epsilon. So, first of E dash is plus comma epsilon and first of T dash is equal to star comma epsilon. So, you have computed first of all the non-terminals. This requires the first of all the terminals which was indirectly computed. Okay. So, first of open parenthesis, first of ID is ID, first of plus is plus, first of star is star, first of epsilon is also equal to epsilon. On to follow. Now, follow of E. Okay. Look at the production, F produces parenthesis E close parenthesis. So, in that example, now this is my alpha, this is my B and this is my beta. Okay, alpha, A, beta. Follow of A contains first of beta. Okay, follow of A contains first of beta. Therefore, follow of E will contain first of close parenthesis. That is the rule. Okay, so one thing alone I am showing, the others I will just say it as a production. So, follow of E contains first of close parenthesis. And anyway, follow of E has E is a start symbol. So, follow of E will contain a dollar. So, dollar comma close parenthesis. I am just looking at this only as of now. I do not have any other rule to apply for this particular production. Now, follow of T. So, I have two rules for productions for T. T produces F T dash and T dash produces star F T dash. Okay. And similarly, E produces T E dash. Okay, E produces T E dash and T dash produces star T E dash. Okay. So, looking at E produces T E dash, follow of T contains first of E dash. That is from the first production, E produces T E dash. And then that is from T produces, E produces T E dash. Okay. T E dash, this is my production here. So, from this follow of T contains first of E dash, that is what I have got here. And where will I get this from? Basically E dash produces, okay, E dash produces plus T E dash, okay. This is one more production I have, E dash produces plus T E dash. Now, this E dash also produces epsilon. So, this is your alpha, A, beta and first of beta contains epsilon. Therefore, follow of T will contain follow of E dash, the second rule. Okay. Follow of T contains follow of E dash. So, that is what we have got here, first of E dash union follow of E dash. Okay. Applying a similar corollary, we will go with the other rule. So, plus dollar. So, first of E dash has got a plus. Okay. Follow of E dash, to know follow of E dash. To look at follow of E dash, let us look at follow of E dash. So, follow of E dash is equal to follow of E. So, how will I get that? So, because E produces, okay, E produces T E dash, this is my production, okay. E produces T E dash is my production. This is my alpha now, this is my B. So, follow of B contains follow of A. Using that logic, follow of E dash is equal to follow of E. Therefore, this has got a dollar and a close parenthesis. Similarly, follow of T dash is equal to follow of T because T dash produces F T dash. Okay. T produces F T dash is there. So, T produces F T dash, this is my alpha, this is my T dash. So, follow of T dash contains follow of T. So, again using that logic I have follow of T. So, follow of T is dollar plus comma close parenthesis, therefore, follow of T dash contains dollar plus and close parenthesis. So, looking at the follow of T, follow first of E dash union follow of E dash, follow of E dash is nothing but follow of E, which is dollar comma close parenthesis. I am adding to that plus. Now, follow of F contains first of T dash union follow of T. We have just now seen that. So, T produces F T dash is there, T dash produces star F T dash is there. Using star F T dash, follow of F contains first of T dash using the fourth production, and follow of T using the logic that T dash produces epsilon. So, it is first of T dash union follow of T. So, first of T dash is star and follow of T just now we have seen plus dollar comma close parenthesis. So, using all these rules we are able to come up with the follow set. Okay. So, follow is got 4 rules. First one is adding dollar to the start symbol. Second one is looking for the production of the form A produces alpha, B beta. So, follow of B contains first of beta except epsilon. Okay. Then if beta has got a first of it as epsilon, then this production reduces to A produces alpha B. In that case, follow of B contains follow of A. So, that rule we have to apply. And the last one is if there is a direct production A produces alpha B, follow of B contains follow of A. So, looking at applying all these, now this alpha can be epsilon, prefix can be epsilon basically. So, that is assumed, and based on that we have come up with the following follow computation for this particular example. Okay. So, this is what we just now saw, follow of E dash is equal to follow of E based on these two rules actually. And one more example, let us take this example, if condition then statements S dash or A. This is what we left factored the grammar and we got this grammar in place, I, C, T, S, S dash or A, and S dash produces E, S or epsilon and C produces B. So, this is the grammar which we basically got. Now, the terminals in this grammar are I, T, A, E, epsilon and B. Non-terminals are S, S dash and C. Now, this is very simple actually. First of S is going to be I comma A, first of S dash will be E comma epsilon and first of C is going to be B. Okay. So, first of S is I comma A, first of S dash is E comma epsilon and first of C is equal to B. So, this is very obvious. And to look for follow, so I have to look at this production. Okay. Now, this is alpha, I is alpha, this is B, C is B and this is beta. Okay. So, follow of C contains first of T, that is one rule. Follow of C contains first of T, and the next rule will be follow of S contains first of S dash. Okay. Follow of S contains first of S dash, and here follow of S contains follow of S dash. So, 3 rules only are applicable here. So, using that, so we already computed. So, follow of S is equal to dollar comma E. How is it becoming dollar comma E? Follow of S will anyway have dollar and follow of S will contain first of S dash. Depending upon that you got E here. So, dollar comma E, and using the second production S dash produces ES. So, follow of S will contain follow of S dash, and using the first production S produces alpha A. What is A? A produces alpha B. So, B is S dash and A is going to be S. So, follow of B contains follow of A. So, follow of S dash and follow of S are going to be same from the first grammar production. And the last one is going to be follow of C. Follow of C is not used, therefore, I have not indicated here. Follow of C of course will contain T actually. Okay. Now, so far what we have seen is, we have seen left factoring the grammar. We have also seen computing of first and follow for the two conditions. By one grammar we have done left recursion elimination, and the other grammar we have basically left factored and we have computed first and follow. Now, after this we have to construct the predictive parsing table. Now, the predictive parsing table is done based upon this particular logic. All the non-terminals will occupy the rows and the columns will be your terminals. Okay. Non-terminals will occupy the row and the columns will be your terminals. the table entry will be a non-terminal comma symbol combination that will have the production that matches the non-terminal comma symbol component, okay, where the symbol is available in the first of the non-terminal, okay, where the symbol is available in the first of the non-terminal. Now, if the first of the non-terminal has got an epsilon component, then you add the production non-terminal produce epsilon in all non-terminal comma a for all a belonging to follow of non-terminal. So, this is very simple actually. So, the table will have non-terminals as a row and columns as terminals, and you will have to look at the first of all your non-terminals. Now, at the intersection of this non-terminal and its first symbol, okay, this symbol is actually the first symbol, okay, you will add the production that matches the non-terminal comma first symbol character. On the other, supposing the first can also have an epsilon value. If it has got an epsilon value, then you go to the follow of the non-terminal, and how many ever components are there in the follow of the non-terminal at the intersection of this non-terminal and that symbol a for all a in follow of non-terminal, you add the production non-terminal produces epsilon, okay. So, these two rules are applicable used for constructing the predictive parsing table. Now, this is the predictive parsing table for the expression grammar. We already know first of E contains open parenthesis ID, first of T contains open parenthesis ID, first of F also contains open parenthesis and ID. E and T has got one production each. E has got only one production, T also has got only one production. So, at the intersection of E and ID and E and open parenthesis, you add the production of E, okay. You add the production of E, which is E produces T E dash here, and this is going to be T produces F T dash. And the follow of F contains ID and close open parenthesis. Now, F has got the first as ID from F produces ID, this particular production. So, at the intersection of F and ID, I add F produces ID. Similarly, at the intersection of F and open parenthesis, I add F produces open parenthesis E close parenthesis. So, this is how you generate the parsing table, and based on that you will use it for parsing your input string. So, first and follow were computed, parsing table was computed, and based on that we will go in with parsing a given string for any particular language. Thank you.